Hey, what's going on guys? My name is Madison Charlton from MLC Tech, and today we're going to be going into a report on a brand new UEFI vulnerability, and this vulnerability allows an attacker to creep in via a user's network and infect connected devices with a malware that runs at a firmware level. So sit back and relax as we dive into the PixieFail vulnerability and what this could potentially mean for data centers and potentially even user data. Now, this vulnerability mainly poses a threat to public and private data centers, and of course the users that use their services, so this vulnerability isn't going to affect the UEFI of a typical consumer computer. But this vulnerability is very dangerous because even people with minimal access, such to a network, or let's say a paying customer or a low-level employee, or any attacker who's already gained limited entry, can then exploit this vulnerability to infect connected devices with a malicious UEFI. Now, for those of you who don't know what UEFI is, it stands for Unified Extensible Firmware Interface, which is essentially the modern version of a computer BIOS, and this is the low-level and complex chain of firmware responsible for booting up and controlling virtually every modern computer. And by having an infected UEFI, this malicious firmware will run prior to the loading of your main operating system, and this can be very devastating as a UEFI infection can't be detected or be removed using traditional methods such as running an antivirus and running other additional scanners on a file system. And as the UEFI runs at such a low level, this gives complete underlying control to the system as a whole. Now, PixieFail comprises of 9 separate vulnerabilities that reside in the Tiana Core EDK2, which is an open source implementation of the UEFI specification. And this implementation of the UEFI is incorporated into offerings from ARM, Inside, AMI, Phoenix Technologies, and of course the biggest one being Microsoft itself. And the flaw in this UEFI resides in the functions related to IPv6, which stands for Internet Protocol 6, and this can then be exploited in what is known as a PXE or a pre-boot execution environment when it is configured using IPv6. Now, PXE, sometimes referred to as PixieBoot or NetBoot, is a mechanism that enterprises use to boot up large numbers of devices, with its usual use case being large servers and large data centers. Rather than the OS being stored on the device that you're actually using, PXE stores the image on a central server known as a boot server. Then the device you are starting up locates the boot server by using DHCP, otherwise known as Dynamic Host Configuration Protocol, which then sends a request to the server for the OS image itself. Now, PXE was designed for ease of use and to make sure every instance of an OS followed a uniform structure and, of course, quality assurance inside of data centers and cloud environments. And this makes OS deployment so much easier, as when you're updating or reconfiguring an operating system, admins only need to do so once, and that ensures hundreds or thousands of connected servers run it each time they boot up. So instead of having to manually configure every device on the network separately, you can just deploy one OS image and it will update all the devices automatically. But jumping back to the PixieFail vulnerability itself, what this means is that an attacker can cause servers to download malicious firmware images rather than the intended ones. When you load up your system and this vulnerability is present, it means that a malicious version of the OS image will be loaded into your system and you will not be able to tell the difference until the damage is already done. And these malicious OS images could include all sorts from info sealers to other backdoors that could control your system. The dangers of this exploit could be pretty severe. An attacker doesn't need to have physical access neither to the client nor the boot server. The attacker just needs to have access to the network where all the systems are running, and it needs to have the ability to capture packets and to inject packets or transmit packets within the network. When the client-based server boots, the attacker just needs to send the client a malicious packet in the request response that will trigger some of these vulnerabilities. The only access the attacker needs is to just have access to the network, not physical access to any of the clients, nor to the boot server or DHCP server. All they need to do is just capture packets or send packets to a network where all of these servers are running. And for PixieFail to be exploited, PXE must be turned on, and for the overwhelming of UEFIs in use, PXE isn't turned on by default. Now, this is generally used only in data center and cloud environments for rebooting thousands of tens of thousands of servers. Additionally, PXE must be configured in combination with IPv6 routing. So not every UEFI is going to fall victim and be vulnerable. It's only if you have a few conditions set within your UEFI where these vulnerabilities can be exploited, though this is pretty significant that use PXE deployment. Now with PixieFail, there are a whole range of different vulnerabilities comprising of this. This could range from buffer overflows to integer underflows, both of which allow for remote code execution. Now, if you would like to read more into the individual vulnerabilities of this exploit, then I will have it posted in the description down below. Now, the makers of the affected UEFIs are in the process of getting updates pushed out to customers, and from there, those customers are making patches available to their customers, who usually are end users. Now, companies such as AMI confirm the vulnerability affects its Optio V line of firmware, and it has said it has made patches available to its customers already. Whereas one of the larger customers, that being Microsoft, issued a statement that said the company would take an appropriate action without saying what this was. Now, Microsoft also claimed in an error. Now, Microsoft said that exploiting the vulnerability requires the attacker to first establish a malicious server on the affected network, which when looking into this exploit, no such requirement actually exists to execute this attack. As we already mentioned, an attacker only needs to be able to send packets within that network, and also the proof of concept code, which is sent to all vendors of this UEFI, including Microsoft, does not set up any servers whatsoever. But for now, Microsoft only recommends that you disable unused boot capabilities and only using PXE or other protocols only on trusted networks only. And they recommend for now only using TLS over the internet. And at the moment, the other vendors affected by this vulnerability, such as ARM, Inside and Phoenix, haven't made any comment on this vulnerability as of yet. Now, PixieFail isn't something that most people need to spend time worrying about. The vulnerabilities, however, are definitely something that cloud environments and data centers need to care greatly about. After all, this exploit allows someone with limited network access to suddenly have a backdoor to your server and network environment. And if this isn't resolved quickly, this could lead to an entire fleet of networks becoming infected. So if this vulnerability goes without any form of rectification, then this could have serious impacts on a whole range of services and end users that rely on cloud services and also large data center users. The fact that users could become infected without even knowing, and the fact that this can be then executed with such little effort or access is absolutely crazy, and this is a very serious vulnerability in these UEFI systems. Now that's going to be it for today on the PixieFail UEFI vulnerability. Let me know all of your thoughts and opinions in the comments down below on this vulnerability, and what do you think that this means for data services and cloud services as a whole. Are you greatly concerned about the impacts that this vulnerability could have? Let me know all of your thoughts and opinions around it in the comments down below. Anyway, I have been Madison Charlton from MOC Tech. Thank you so much for watching today's video. If you like this type of content in any way, shape or form, make sure to give it a like and maybe subscribe for more content like this in the future. Thank you so much for watching, and I hope to see you in another video soon. Goodbye for now.